On YouTube, Daniel Moffat here. Okay, so I've been doing some more aluminum welding, and we also have this very storied aluminum frame. Chunk missing there, but it's okay because we bolted on a new bash plate. So we'll get to that in a second. I'm jumping the gun here. So in some of my previous videos, I aluminum welded this thing first. And you can see it's pretty well, I aluminum brazed or aluminum soldered. I'm not really sure, but let's get back to that. So I had a couple of those aluminum rods, those aluminum brazing rods, and yeah, I liked them. They were interesting. So I mean, we did a few pieces. We did this one as well. And if you're wondering if they looked like this when I started, no. These were flat, smooth. I'm just really lazy, pretty much majorly like uncleaned pieces of aluminum. So I think it's very interesting that the bag on this thing says aluminum brazing and welding rod, because you find yourself going like, well, is it welding or is it brazing the aluminum? And I think it was doing both. So I think if you do in that temperature range that it tells you, that's 720 to 750, and I have no idea what temperature range I was in before, but we picked this bad boy up, so we're going to be able to say with a little bit more, definity, like what temperatures we're actually getting at. But this is my theory, is that if you go into that 720 range, you just get soldering, or you get brazing, excuse me, because you can get the metal hot enough that when you feed the rod into it, you can get it up to a temperature that you feed the rod in, the rod starts to melt, and it'll flow around the pieces. And this could be just because I'm lazy and I'm not cleaning them very well. But I mean, the aluminum, the solder, the brazing rod, whatever, it'll puddle at a much lower temperature than the surrounding aluminum. So it got to a point where, like, what I was first trying to do with these is I was trying to put them together like sideways like this, and I was having no luck. The aluminum would like go under it, and it would start like, you tilt it, and like all of the aluminum would like bubble to the edge and then just like fall off, and that's what gave me these big chips, which you can actually reuse, interestingly enough. So yeah, so I would get it really hot, and like the solder would start to melt, and then it would just like puddle and blop. And I think that's where the brazing is like, if you just get the aluminum just hot enough to melt the rod, then you're brazing. But as you can see from these, I got these probably much hotter than 720, closer to around 1,000 probably, to get the outside skin to start to, crinkle. But this one is really evident, like, and the reason it's bent like this is not because I got it so hot that it fell over. I actually, to test my welds, and these are welds because I got them hot enough to look how hot I got this. The bar started to deform and crinkle from all the heat. But then eventually they did weld. Like, once I fed, like, if nothing else, you can use these aluminum brazing rods as kind of like to encourage the metal to go together. Like, I just started like join after it got really hot, and then it starts to feed in, and it starts to like I don't know if you've ever put like gallium on aluminum or watched a video like that. It like amalgamates like that at room temperature. It kind of looks like it does that. Like, the aluminum bar looks like it'll like suck it up, and it won't just be like, you won't be able to shake it off. So I think there is a point where you're brazing if you're under a certain temperature. I think there is a point with like this. This is me trying to break this apart. That's why this is bent like this. Where you're actually welding. The same for these. Like, there was a point before this when I was just brazing them, when I wasn't getting them to the point where they would liquefy, where I would put pliers on them and I could just, they were together, like solid, like brazed, then you just pop them off, just give it good, twist. But you can see there's score marks from the pliers in this one where I tried that, and now they don't come apart because I got it to the point where it was liquefying. And so the brazing amalgam rod I fed in was actually welding it. So you can't weld with this. So I think there's a difference. And this metal, so I mean the point of this was to meld this inner piece is from like an aluminum frame like this. Not this one per se, but one like it. And these two rings are off of these tabs. So we're trying to see if we can weld this tab to a frame like this, because these are going to be different kinds of aluminum. And like I can tell you just from how long it took to kind of like liquefy these two different kinds of aluminum, this aluminum and these rings is a much higher density than this interior aluminum, because the interior aluminum took to the, from the frame. This probably means that these have like something like tin or copper or brass, or there's something in these to make them a teeny tiny bit have like a higher specific heat than just straight up aluminum. So that's why when I was heating it, when I finally did get these to weld, I had to focus most of the flame onto these two parts and basically just let the ambient temperature heat this up, and that worked a little better. So enough talking, enough jibber jabber. Let's so okay, let's a little more jibber jabber. So we're going to talk about this frame for just a second here. So if the keen-eyed observer will notice that this was the frame that I was planning on using for my KX500 AF bike. This is an '08 RMZ250 frame, and boy, we took it had a steel DRZ400 frame like cut out and put into here so that I could put a DRZ400 swing arm in here, which it had. But before we did that, we had the DRZ400 swing arm in here. If you look really close, there's a notch out right in here, because before I decided I was going to put my KX500 motor in here, I had already, and cut this Y out, I had already successfully mounted a DRZ400 motor in this aluminum frame to try to build an aluminum frame DRZ400, because I thought I wanted something lighter, more powerful. But a DRZ400, it's like trying to take the heart of like a sea cruise ship and try to put it in something like a Civic or something. It's just too big. It don't work. It didn't work. So after I got the KX motor, then I decided I was going to cut this frame and move the Y up and re-weld it. After I'd already, if you've seen that other video, it's just laughably sketchy. So since I was planning on making this my KX500 AF, I bought everything for it. I have plastics. I have a really nice $300 seat, like a $200, $300, $400, $500 gas tank, and I have brand new radiators for it. And this is trash essentially to me, because I'm not going to use it because it's sketchy. But all those, and I would try to sell all those parts, $700, $800, whatever. I probably spent $1,400 on all the parts for this thing. So it's one of, it's like, woo, great. I found a better frame to put the KX500 motor in. It's a KX250F in '08. Funny enough, same year. But I have all of that bike already. I literally have an entire KX250 '08, so I don't have to do any more. I was going to have to probably melt that really expensive gas tank that I had, because the KX was going to stick up in here, and it was like an oversized 3-gallon tank, so I was going to have to heat it up and melt the super expensive fancy tank. So it's in it has a new frame. I actually haven't built it yet, but so what we did do, so this is a DRZ400 bash plate. So instead of using it on something else that it doesn't go with, I'm just going to use it for this, So we went and we drilled a through hole just to put a little pressure, and the zip ties were to hold it in place initially, obviously. So, yeah, it's got, I think these are KTM standoffs. I left all my other bolts at home, at my mom's house, actually. So there's one on this side, and then there's one on this side. So I can actually go ahead and snip all of these zip ties off. They are no longer needed. That was just to kind of hold the bash plate level while I, there we go, while I drilled it. And, so my plan for this is to just stop trying to sell all of that expensive accoutrement, the whole top end that I bought for this bike. I think I actually bought the subframe also. I bought this to build this bike. It's funny that it definitely has like $100 pegs. It's got fly like racing pegs. I mean, like I was spending money. This was going to be my bike. It's kind of a kick in the pants to find a slightly better suited frame, especially since this one was just so gutted from all of my my idiocies. But it's gonna make so because I want to weld these, getting way off topic here. So because I want to put these aluminum brackets on my CR 500 AF frame, I've been experimenting a lot with the aluminum welding, and so this is gonna be like kind of an interim project to help kind of hone my aluminum welding skills. So I have more bars like this is from a xylophone, some different, another like pretty dense aluminum. You can see how hot I had to get these to weld. So I have more of these, a different, one kind of aluminum, and this frame is going to be another kind of aluminum. And this bash plate, I can tell just from drilling through it, is probably just pure straight aluminum. So this is probably some kind of alloy, and this is probably some kind of alloy. So I'm going to use these, and I'm going to, cut them into like little triangles and we're going to try to braze, weld, we're going to get our heat gun and piece of metal just fall out of that? No, it's definitely a piece of slag from, see, that's what I was talking about, that slag is falling off of the, oh, where'd it go? Yeah, this is just some of the, I can probably reuse this actually. This is the brazing material, the aluminum brazing material. I wonder what's in it to make it braze like that. Like maybe like lead or just like a teeny tiny bit of gallium or something. Who knows? Some trade secret, I'm sure. So yeah, so we're gonna be aluminum welding all of this together. And this is going to be, I also have, oh, let me go show it off. It's awesome. All right, we have this bad boy. This is a Yamaha Zuma 50 motor, and this is going to come into play with a little bit of my my aluminum practice too, because I'm going to use some of those xylophone pieces. Let me see if I can fix this. I bought this motor like this. I actually put the head on it. I was going to try to sell this too, but I think I'm going to try to use it for that frame. I'm going to try to fix this. I don't even know. I don't even know if I need this hole anymore. I might just cut that whole thing off. So we're going to rebuild this motor. Let's take it out there. Let's go see what it looks like on the bike. Okay. So yeah, so this is a Yamaha motor. A Yamaha Zuma 50. A 50cc, 2-stroke, air-cooled. Very simple, very cool. Okay, so that's kind of, and I raked the bike forward a little more so you can see kind of what it's going to look like when it gets a little more suspension. And then, so since I had I salvaged the DRZ400 at one point, my DRZ400, I'm not sure if you could tell, I had a set of DRZ400 front forks on this, and I shaved it a tiny little bit so they would fit on the top and bottom. So I know a set of DRZ400 forks will fit on this. And they made those for like 20 plus years, which is cool. So if I ever do get around to fixing up the motor, I'm probably gonna weld the frame right now. I'm gonna put bolts in it too and leave it just in case my crappy solders weld. But this will be a little 50cc bike. I'm probably gonna I'm gonna cast some aluminum pieces for this bike too. So this bike's just pretty much just like an aluminum project. Just, just to cut my teeth on aluminum welding, soldering, brazing, whatever. But yeah, that's the plan as of now. So the next thing I have to do is see all those aluminum pieces right there? I need to stop saying, well, I'm just experimenting, so I don't need to clean it. I need to clean between these pieces. And then, I need to take this off and clean it so I can resolder it. So I can, oh man, I'm never going to get it straight. I'm going to confuse it between soldering, brazing, and welding forever. I'm gonna try to weld it. I mean, that's the goal, so get a weld on it. But yeah, this is gonna be my daughter's bike. I'll build this for my little baby daughter. She's 1 right now, so, you know, giving myself a little time. Little 50cc 2-stroke, good starter. It'll be a good solid. Oh, this bike is so storied. This bike has been so many things, and it's gonna be even more things. Yeah, it'll be cool. So we'll see. Let's see. I'm gonna try. I'm gonna take the plate off and clean it up. Gosh, you have no idea how badly I wanted to just not clean these parts. Alright, boom. Apart. Look how responsible I'm gonna be. I'm even gonna sand it and junk. Which, now that I think about it, for more than like literally like 0.1 second, you see that shiny clear coat on it? At one point, I definitely had my friend with like a chemical coating company pay it with some kind of like ceramic coat. So, yeah. Gonna have to sand it, which kind of sucks, but I guess I'll do it. Oh, dear Lord. Okay, hand sanded. That one's good. I think that one's okay. Those, they're okay. These, you know what, we're gonna call it good enough. You know? Because you know what, the other ones I didn't even clean or sand at all. And these, look at this. I even got a little, bust out the 70% IPA. 100% would be better. But, you know, we twerk with what God gave us. Alright. And then just light the whole thing on fire. God, that's what I want to do sometimes. Especially after hand sanding. It's just too late to run the angle grinder. You know? Hand sanding still sucks. Okay. Clean. Alright, so let's bolt these hunks of cart back together. Let's try to solder them together. Braze them, weld them, whatever. It's funny, I was just looking at this bash plate, and I remember this little ding that's in it. I remember because like for the 5 seconds I had this thing on my actual DRZ 500, the second I put it on there, I like attacked a rock with it, basically. I was like, bash plate! Bash the world! Okay, we got ahead and got it all bolted back together. I see a problem immediately. Let me turn this thing so it's a little more in the light. I can see that touches kind of like right here at the bottom. That's kind of where I sanded the least. You can see, and that's probably where I'm going to be welding it. That's where it comes into contact with the metal. So it's funny. It just goes to show you, don't waste your effort, children. Don't do any prep work. Just throw yourself straight at it. No, I'm just kidding. That's probably terrible advice. That's probably why I keep breaking so many things. Alright, let's see. But I am going to go ahead and put this thing back up on its butt. Yeah, since this one looks like the best lined up / sanded, let's try to do... Let's see what temperature it is. Cold. 52. It's pretty chilly here. Okay. Let's bust out the heat gun. I got a lighter on here somewhere. I'll be right back. Okay, found my lighter. Let's try to turn this on without burning me. Okay. Mission successful. This is definitely the way God intended this Bunsen burner to be used. It's a good thing there are no gods or kings here, just men. This thing works as a pretty awesome little like flame torch. Okay. I don't know if there's any way for me to film this. Can that still see? Can I see? Okay. That's how I burned everything down. That actually... I can actually see that it sees that. Okay, so... see what we have. So theoretically, that's weird. At a 260. Wait, what? Oh. Okay. No, that's right. 730 is our, I don't know why that just stumped me so much for a second. Wow, this thing is awesome. 400. Oh. Just kidding. It's kind of dancing around. So this side is 400. This side's like 350. I feel like that's another important point, is that the works both need to be operating temperature. This whole thing, I don't even know if I'll be able to get this thing to this temp, to 700 degrees, because this whole thing is going to act like a big heat sink. A big aluminum heat sink. It's just going to be radiating off. But at least I can know how close it is now. This was freaking worthless without this temp gun. Oh yeah, oh yeah, you're gonna get burned off. Logo. What did you say? Intended for closed course use? Ha! Yeah, you're gonna get burned off. Let's see if I can turn the heat up a little. I need more heat up in ya! There we go. It's gotta be close to the end of this propane tank. It's like 500. We're getting there. We're getting there. I don't even have a brazing rod primed. It's warm all the way down in here. It's not like it's too big, you can say. Got that heat on there pretty good. We're at it's hard to tell because it kind of jumps around. Or at least 500. I wonder if the gas is... Yeah, this, So here's the tricky part. So this thing is... The frame is heat sinking a lot more of the temperature than the plate is. The plate is, shedding its heat a lot quicker. Well, I guess this thing's acting as a heat sink more because it's shedding its heat more than the frame is. The frame is kind of holding on to its heat. And that could just be because the frame is like I said, a slightly different material than this bash plate. Yeah, the plate is kind of holding around 500-ish. And the frame is getting to about 700. So here in not is the issue. We'll put like 80% of the heat on the... Must have been paint on this bolt. I should try this with map gas. It is recording still, right? Yeah, okay. But am I visible? Yeah, I can see it. Cool. Alright, I should probably keep a pretty constant eye on this temperature. On this side it's saying around 650, but on this side it's not even 6 yet. On this side it's not even 5 yet. Oops. Well, I wanted to get rid of this sticker, so I guess this works out. Who knows how much of this heat from this plate is being robbed by the pressure from the steel bolt. Yeah, I'm having a really hard time to get it to... This whole plate is really hot. The whole frame is really hot. It was probably just going to have to do that. It was going to have to spread some of that heat around. You can see that nasty paint coating come off too. We're just gonna cook that whole clear coat nasty color. Oh, they had to get it to 720 degrees. This one's kind of creeping up on... Uh-oh. What does this thing go to? Oh, gosh. Oh! I just said 730 for a second. So I basically don't need to put... Basically, at this point, all the heat needs to go on this thing. Because the frame is already up to town. Yeah, it's there. Like, the frame is there right now. So as soon as we can get the plate to around the same place, it's getting there too. Keep making sure this one's already way too hot. Cool. 760. So again, no temperature needs to go good. He says licking it with the flame. Watch, my propane flame goes out. Still not 720 yet. See, this is the problem, is if I touch it, it'll melt to the frame, no problem, but then it won't weld to this thing. This is probably the ghettoest structural aluminum weld that's ever been done. I mean, I'm gonna leave not these bolts perhaps, but I'm gonna leave bolts in here anyway, so I don't know if it's even really fair to call this structural. I'm trying to make it. I want it to be structural. Alright, let's check the deck. And even this one's coming out a little bit. Ah, man, I don't know. There might just not be enough heat. Yeah, this side gets hot. This side reaches like 760, like, no problem. It's because it's so much thicker. But this thing is like all of this thing pulling all the heat all over it. I need to do this on a freaking hotter day. Oh, we're actually kind of getting there, kind of. Oh, it's getting there. Just gotta keep it centered on this bolt, basically. it's just not hot enough. Man, this thing could take freaking orbit re-entry. The bash plate could, at least, anyway. Shit. I mean, gets there no problem on the other side. Okay. I'm gonna count to 60 and then I'm gonna do it. One, two. 60. Alright. Alright, let's read it one last time. It really just doesn't think it's hot enough, but we're gonna go for it. Definitely not hot enough. Not even hot enough to melt the rod. Damn. I just need to, like, leave this. Man. Nope. Not even close to wanting to do it. I feel like, I don't know. Damn, I don't know. Maybe map gas will be hot enough. This is definitely not my way. Okay. Let's get this one apart. Okay. Oh gosh. Okay. Excuse me. You can see it looks half decent, right? Maybe not on this side. On top. It doesn't look bad. But that's just brazed. Yeah, I know that that's not stuck together. So I think that's the brazing aspect. And let's look on the bottom side. On the side, I tried to stick it along the edges. You see what it wants to do over here, where it wants to puddle. See how that breaks off? Yeah, I'm gonna snip that. Yeah. See how that didn't stick to that? Well, no wonder, because I mean we didn't. Gotta be careful not to melt my phone on this dang thing. But yeah, no, it's not welded. It's just soldered. I think, or it's just brazed. I mean, it looks good, you know, not bad at all. But I know that if I take this off, this will just pop off. If I take the bolts off. So I'll let that cool down, and then maybe we'll give that a shot. I don't know. Should I try to do the rest of it? Oh my god. It's warm all the way down to like here. Oy vey. You see how I had to cook the tits off of this thing? and it still wasn't hot enough. This thing, what does it say it goes up to? 752. Food's ready? Oh, nice. Well, it kept saying OL, which is overload, but that should theoretically be hot enough, you know? Let's see what it says it is right now, actually. 300. That cools down so freaking fast. I should have... Gosh. Well, we'll let this cool down, then we'll come look at it. I mean, it really does not look terrible, but it's brazed. Not welded. Metal glued. Should be nice and cool. One last look at it, you know, before we, like, you know, look how slick wood that looks. Looks like maybe we got a little bit of welding going on up here, but the rest of this, we'll see. I'll take the bolts off, and if it's like really hard to bend it up, I'll stop. Something tells me this is just gonna pop right off. These weren't close enough in temperatures, I don't think. But let's find out. Well, okay. I'll say it's still on there, like it's all the bolts off. It didn't immediately just pop off, so it's brazed on at this point is my guess. But I think if I apply a little it's gonna dishearten me, but yeah, see, click, yeah, so yeah, just not hot enough. Yeah, and you can see it's such a clean line where it's, yeah, I don't even know if it's like really attached to this aluminum. This one was getting hotter faster, it seemed like. Yeah. I mean, this might be welded onto this side. Yeah, so I pried it off for the most part. You can see it did stick a little teeny tiny bit better where I was saying, like, hey, look, it actually stuck a little better. Yeah, see, kind of maybe right there, but in general, just not hot enough. But like, God, it's a chilly night. I should try again on a warmer day. Well, that's it. She's defeated us, not for good, mind you. I'm definitely gonna take another whack at this, but not when it's like 47 degrees outside. I should probably do this on like a 100-degree day. Yeah. I could probably stand yeah, it was pretty hot. It was pretty hot that I was getting this. But this worked pretty good, I think, when I got the flame under here and I was hitting it with the map gas. I'm just gonna need to try again. Yeah, it wasn't hot enough. So, okay. Well, that's all she wrote for now. Till next time.